7, Lesson 2, Solving Exponential Equations and Inequalities. So we're going to take a look at solving these now. So exponential equation, when the variable is the exponent property of equality for exponential functions. So if I can get the same bases, so here, same bases, the 3's are the same, x is then going to equal 5. Pretty basic. Okay? Same idea with inequalities. If I can get the same bases, then I can just take a look at the exponents. X is greater than 6. So let's take a look here. And again, it's not quite that basic, but it comes out to that pretty easily. So 10x equals 10 to the 8th power. Well, in this case, same basis, so x equals 8. Right? Now, a lot of these are not going to have the same basis. So how can I do this? How can I get the same base? Well, 4 is 2 squared. So 4 is 2 squared to the 6th power. Now, exponent properties say power to a power. I take and I multiply these exponents together. So this is really 2 to the 12th power. So x, in this case, equals 12. So get the same bases, and then you can solve it fairly easily. So again, looking at the bigger number here, 25, well that is 5 squared. So now 5 squared to the 3rd power, again, 2 times 3 gives me 5 to the 6th power now. So then x is greater than 6. In letter D, 8. So it's a little harder now. 2 times 2 is 4, that's squared, times 2 is 8. So that 8 is 2 to the 3rd power, taken to the 4th. And multiplying the 3 and the 4, so that gives me 12. So that's 2 to the 12th power. So then x, again, is another 12. (5x less than 125 squared). So again, let's see how many times 5 goes into 125. So 5 times 5 is 25. That's squared. 5 to the 3rd is then going to give me that 125. So this is 5 to the 3rd. Then squared, so this is originally 5 to the 6th power, so x then is less than 6. So take a look at f then. 4x equals 256 to the 5th, so 4 times 4 is 16. 16 times 4 is then going to give me that 256, so this is 4 to the 3rd power, so then taken to the 5th, so overall it's 4 to the 15th power, so then x is equal to 15. So as long as we get those same bases, it's pretty easy. Now again, we can have anything in our exponents. So here we have some expressions as exponents. So same idea though. 9 is just 3 squared, so 3 squared taken to the 2x minus 1. Again, so just multiplying these exponents together. So 2 times 2x gives me 4x. And 2 times negative 1 is negative 2. So 4x minus 2, that's going to equal the 6x. And now we just solve it like with two-step equations. So minus the 4x. And so negative 2 equals 2x divided by 2. So x equals negative 1. And the last one, same idea, 5 into 125, again we had that in letter E there. That is 5 to the 3rd power taken to the x plus 2. So this is 5 to the 3x plus 6 power, and then multiply that together. And then those just equal each other. So 5x equals 3x plus 6. Again, let's get our x's on the same side. So that leaves me with 2x on the left equals 6, and divide by 2, x then equals 3. So that is solving exponential equations and inequalities. Okay? So let's take a look here. We have a word problem application here. So remember from 7.1 exponential equation in this form, okay? A is the initial amount, okay? Y is the total after so much time, and B indicates the growth or decay factor, okay? So in 2000, the population of Phoenix was 1,321,045. By 2007, it was estimated at 1,512,986. So we're an exponential function that can model the population of Phoenix. So we need to kind of figure out what is that growth factor. So the end was 1,512,986. The initial was 1,321,045. This is our growth factor, this B value, okay? And in this case, our X, okay, our exponent, we know it went from 2000 to 2007. So that's going to give us 7 years. So that's going to be a power of 7. We just need to find that B value. So we're just going to solve for B. So we're going to divide both sides then by 1.3 million here. 1,321,045. 1,321,045. So this just gives me 1 on that side. And when I simplify that down, so this gives me 1.145, and it keeps on going. Big decimal here. And then, so that's going to equal B to the 7th power. Now to get rid of that root, remember, or to get rid of the power, roots and powers cancel each other out. So we're going to take this to the 7th root. So we're taking the 7th root of that value then. And so when I calculate that, I then get 1.0196 being my B value. So my equation then is the initial 321 and 45. B value is now this 1.0196. Now we did round that off, okay? And then exponent is x now. So now we want to know, what about in 2019? So from 2000 to 2019, that's going to give us 19. So now we're going to plug in this 19 into our exponent for our time to the 19th power. We can plug that into our calculator, and we get 1,910,220. Again, we're talking about people, so round it off to the nearest person there. So people, always round people down, okay? So don't ever round people up, but always round them down. So that is our application problem there. Alright, we got a couple more word problems here. So we have compound interest. So again, this is one that would probably be pretty useful down the road. How much money can I invest? How much am I going to get back in return? Okay, so it's just a formula here. Okay, so the amount equals the principal, which is the initial amount, times, and it's very similar to our growth formula. 1 plus R is the rate, divided by N. N is how many times it's being compounded. Okay, and you can see these compounding here. Annually is just once, biannually is twice, quarterly 4 times a year, monthly 12 times a year. Okay, and then again that compounding period times the amount of time, years. Okay, so let's take a look here. Example 3: an investment account pays 5.4% annual interest compounded quarterly. quarterly, 4 times, right? If 4,000 is paid in this, placed in this account, find the balance after 8 years. So 4,000 initial amount times 1 plus interest rate. Again, that's got to be in a decimal, so 0 point, moving it twice, 0.054, 0.054, okay, divided by how many times it's compounded? 4 times, again, that compounding as an exponent times the amount of time, 8. So we can kind of simplify this down. If you want, you can plug it straight in the calculator just like that. Especially if you're using Desmos, as long as it looks just like this, you are good to go. So when I plug that in, I get 6,143.56. Okay, $6,143.56. That's again after 8 years. So you made over $2,000 in 8 years doing nothing but investing that money. Alright, so the last example here, we have a screenshot of savings accounts. Again, this is pretty high compared to today's time, but if you deposit 500 into a new city account, city right here, there's our APY, annual percentage yield. So how much money would you have after 1 year? How much would you have after 18 years? And how much after 30 years? So let's just set this equation up. So initial amount is 500 times, again, growth, so 1 plus our rate, 1.85 over, how many times is it going to be compounded? Assume interest is compounded monthly, so that's every month, so 12 months, 12 again, times, and now our time. So our time, we have 3 different times. We have 1 year, so we're going to plug in a 1 in there. Then we're going to have 18 years, so we're going to plug in 18, and then we're going to plug in a 30. So for 1 year, okay, so t equals 1, we would get, plug that in, we get 509.33. Okay, $9. We made $9 in a year. If I plugged in 18 years, we get $697.39. And then if I plug in a 30, I get 870.6. Again, that's just a savings account, very low yield on return for this. Alright, those are your notes for section 2.